Okay, it's about time, so let's get started. Hello, everyone, and welcome to today's Games, Networks, and Decisions seminar. It is my pleasure to introduce to you our speaker, Nicole Immorlica. Nicole's research lies broadly within the field of econ CS, and she is one of the leading researchers in the area. Using tools and modeling concepts from both theoretical computer science and economics, Nicole hopes to explain, predict, and shape behavioral patterns in various online and offline systems, markets, and games. Her areas of specialty include market design and social networks. Nicole received her PhD from MIT in 2005 and then completed 3 years of postdocs at both Microsoft Research in Redmond and CWI in Amsterdam before accepting a job as an assistant professor at Northwestern University in 2008. She joined Microsoft Research in 2012. So we are delighted to have you as our speaker, Nicole. Thanks for joining us. Before you start, let me just make a very brief announcement for the audience. If you have questions during the talk, please type your questions in the chat and we will relay them to Nicole. We'll also have time for Q&A for longer questions at the end. At that part, we encourage you to just unmute yourselves and ask those questions directly to Nicole. With that, I'll give the floor to you, Nicole. Thanks again for joining us.
Thank you. And just to make sure, this is an hour-long seminar?
Yes.
Okay, great. Thanks. So I'm going to be talking today about communicating with anecdotes, and this is joint work with Nika Hagtalab at Berkeley, Brendan Lucier and Marcus Mobius, who are my colleagues at Microsoft Research, and Divya Mohan, who is a graduating PhD student at Princeton University. So in the standard econ model of communication, you have a sender and a receiver and some state of the world. And the sender has some information about this state of the world. She observes some information privately and then uses this to update her beliefs about the true underlying state of the world. She then perhaps selects an action based on her beliefs and communicates some message to a receiver who, upon hearing the message, updates his own beliefs and also selects an action. And then the sender and receiver each receive payoffs that are based on the state of the world, their personal preferences or type, and the actions that have been selected by both of them. So as an example of this might be the state of the world is whether the economy is robust. The sender has some detailed information about the economy. She can observe, say, that inflation is rising. Maybe she also observes some information about interest rates and documents from the Fed. And based on all of this information, she updates a complex model of the economy and concludes that a recession is likely. She can then maybe divest in the economy and send some message to a receiver about the probability of a recession. It could be the probability of her belief that a recession is going to occur, or maybe all of the complex modeling information she received to update her own model of the economy. And the receiver listens to this message, updates his own beliefs, makes a conclusion, and takes an action accordingly. In the persuasion arm of the literature on communication, the sender might have differing incentives from the receiver and therefore might try to send messages that could persuade the receiver to take particular actions, like maybe she would rather that the receiver invest than divest, and so she can bundle together some of the bad states of the world in which the economy is doing poorly together with the good states of the world in which the economy is doing well, and committing to that bundling of states of the world, she can sometimes convince the receiver to take certain actions that are in her own benefit. So this is kind of like, the standard stuff. And what we were interested in is thinking about how all of this plays out in a setting in which we have anecdotes. So what are anecdotes? Anecdotes are experiences that we have when we interact with the world. You can think about them in our formal model. We'll model anecdotes as being simply samples that are parameterized by the state of the world. And so based on these experiences or these anecdotes, the sender updates her beliefs and you select some action, and what she can communicate to the receiver aren't arbitrary models or belief statements, but rather just the anecdotes that she has herself. So she can relate experiences to the receiver. For example, if they're thinking about the state of the economy, maybe the sender knows like her neighbor lost her job, and she can tell the receiver, hey, did you hear my neighbor was laid off? And if she wants to try and persuade the receiver of something in particular, say like to invest in the economy, or say that there is no recession, she can select which experiences, which anecdotes she chooses to relay. So maybe her mom also lost her job, but her son got hired somewhere. And so instead of talking about the people that have lost their jobs, she might tell the receiver, hey, did you hear that my son got hired? So just to like make this super clear, let me tell you about the main distinctions I have in mind between the literature and what we're interested in, the standard literature and what we're interested in investigating. So in the standard literature, there are arbitrary signals that are correlated with the state of the world. And then the messages could be arbitrary messages that the sender sends to the receiver. And these could include beliefs or very complicated models, in-depth models like we see in research papers. On the flip side, with anecdotes, I'm thinking about having a finite set of anecdotes that are samples from the state space. These are experiences you might have about losing a job in the previous example, or maybe eating ice cream cone and feeling sick. And then what's communicated are these anecdotes themselves. So for example, here's a tweet that I thought might be comforting to the people in this call. This was tweeted a couple days ago at ACM Sig Ecom from a referee saying that 11 papers is simply too many for an EC reviewer. And so this is, an anecdote about that particular referee's experience. And Twitter is, full of anecdotes. Another example is journalism. So there is a whole, part of journalism, which is investigative journalism, that really tries to build out deep models. But a lot of journalistic stories are simply stories. And here's an example from the New York Times reporting on Obamacare. And the article talks about a particular woman, a hairdresser, and her experiences with losing healthcare when she was cut back in her hours at her job as a hairdresser. Another example that I wanted to raise here before moving on, and I think this might be a good one to have in your mind when we go through this talk, is recommendation letters. So this is another thing that's close to our hearts. When you are on a committee trying to decide who to hire, you receive recommendation letters and you go to the committee meeting, and you often will, these recommendation letters contain a bunch of anecdotes that the recommender is sending to you about, like, so-and-so had a really clever idea about how to prove this theorem, and that was really what enabled us to move the paper along. And so then in the committee meeting, you'll often see people quoting exact quotes from a letter. So they'll highlight that sentence and they'll present that at the committee meeting. And maybe if the person that's quoting the letter wants to convince the committee to hire this individual, they'll pick out the good sentences. And if they're less enthusiastic, they'll pick out the less enthusiastic sentences. So the questions that we want to ask is, when we're communicating with anecdotes in this manner, is there an efficient transmission of knowledge? Like what is learned by the receiver? Is there in fact bias in what is communicated to the receiver? And if so, what and when? And finally, does this result in polarization about who communicates with whom? And at a very high level, what we're going to see is in our model, well, naturally, if we're communicating with these anecdotes, this is really a coarsening of a message space. And so naturally, it's going to be noisier than if you could communicate arbitrary messages. And this will be especially so if the sender is unable to commit to the selection of the anecdote in advance. This then leads to a natural bias in what is communicated. So if the sender is unable to commit to a signaling scheme, then the sender is going to be tempted to try and persuade the receiver if their preferences aren't aligned. And as they try to persuade the receiver, they're going to be choosing anecdotes that are less representative and therefore have higher variance. And that leads to an answer to the third question about polarization, which is that if the variance, if preferences aren't aligned, you're getting less representative anecdotes. You still are going to rationally debias the anecdotes that you receive, but they're still noisier than the anecdotes you would receive if you talk to somebody whose preferences are more aligned with you. And so this kind of communication is going to lead to polarization in who communicates with whom. So before I tell you the details behind these answers to this question, let me first fix a model in your minds. So I have a sender and a receiver. There's some single dimensional decision they must take, an action. And in the absence of any information about the state of the world, they each have some ideal point. I'll be calling this their moral stances. There's also a state of the world. And if the state of the world is known, then the sender and receiver each want to balance their action between their moral stance and the actual state of the world. So they have some penalty for the distance of their chosen action to the state of the world that they weight against the penalty for the distance of their action to their moral stance. And so their action that they'll take is some convex combination of the state of the world and their moral stance. Now, in the model, we don't have the state of the world is not known. And so they can only learn about it through their experiences. And in particular, we assume that this state of the world is drawn from a diffuse prior. So it's equally likely to be anywhere. But there's some single peaked symmetric distribution from which anecdotes are drawn. This is a common prior known to both the sender and the receiver, but only the sender observes the anecdotes. And so upon observing the anecdotes, the sender can now create some posterior belief about the state of the world and will then choose an action based on this posterior belief and her moral stance. The sender also is going to select a communication scheme. So this is going to be a mapping from the anecdotes that she's received to the selection of a particular anecdote. And so we're going to restrict her to having just one anecdote that she can then choose to send to the receiver. So perhaps she chooses some communication scheme, pi s, which selects an anecdote, the second one from the left in this picture, and she's going to send that anecdote to the receiver. Now, the receiver is going to update his posterior belief about the state of the world based both upon the signal that he's received from the sender, as well as his belief about what signaling scheme, what communication scheme the sender has selected. We'll call the receiver's belief about the sender's communication scheme pi r. Now, using this updated belief about the state of the world, the receiver also chooses an action that balances between his belief about the state of the world and his moral stance. And the sender's goal is going to be to choose a signaling scheme that minimizes this disagreement cost. So this is like, how much friction there is between the actions that have been selected by the sender and the receiver. So the sender wants to minimize the distance between her action and the receiver's action. But if you want to think about this as a utility function, notice that this is the second order term. So the sender is not choosing an action to try, like the sender's action is chosen explicitly based on the moral stance and the state of the world. This is a secondary consideration for her that she wants to then communicate something that's going to minimize the distance between the action that she's committed to and the action of the receiver. And so in this model, we're going to find three results. I'm stating them informally on this slide, and we'll go through them in the course of the talk. The first informal result is that when you're communicating with anecdotes, the optimal scheme is going to send the anecdote that's closest to some shift of the posterior. So the shift is going to depend, as we'll see, on the difference in moral stances between the sender and the receiver. But it could be, for example, if their preferences are totally aligned, then it would be the case that the optimal scheme is going to send the anecdote that's closest to the sender will send the anecdote that's closest to her own posterior. So the most representative anecdote, if you like. Whereas if the moral stances are misaligned, then the sender will choose an anecdote that's closest to some shift where the shift is dependent on the difference in moral stances. And so any optimal scheme has this, it comes from this class. We'll then see that with commitment, the asymptotically optimal scheme, no matter the difference in moral stances, is going to send the anecdote that's closest to the posterior and hence is unbiased. Whereas without commitment, the shift, this shift in the optimal scheme is going to grow both with differing moral preferences. So as the moral stances are farther and farther apart, the shift that the sender applies is going to be growing. And additionally, the shift will grow as the number of anecdotes that the sender has access to grows. So we'll see all of these more formally in in the remainder of the talk, but I want to point out that there's several caveats to this. There's some assumptions, technical assumptions we make in the context of the paper, and that's why I have little stars next to all these theorem statements. So just quickly before I get into the details of the paper, I wanted to mention some related work. So there's obviously the seminal papers of Kamensa and Genskow, as well as Crawford and Sobel, looking at arbitrary signaling schemes. So Kamensa and Genskow characterize the optimal scheme with commitment in these worlds, and Crawford and Sobel look at how signaling without commitment is more informative when preferences are more aligned. Then we go into the literature on disclosure. So because we're forced to communicate anecdotes without any, massaging of the anecdotes, this is closely related to the literature on voluntary disclosure as well as hard information. And so in those worlds, Grossman and Milgram look at models of disclosure without commitment and observe that you get full unraveling. That's kind of the classic results. And then there's been a stream of literature since then looking at scenarios in which the unraveling is only partial. So the world doesn't fully unravel. And so there's some papers showing that conditions under which you get partial unraveling related to uncertainty on the receiver's part about what the sender's information is, or some multidimensionality in the state of the world. And so our paper can be viewed in this line as we'll see, we're going to get partial unraveling in this world without commitment. And that will be due to the noise of the information at various points in the anecdote space. So let me go over the talk plan. I'm going to first tell you about the senders and receivers' perspectives and their best responses, get some preliminary results there. Then we'll talk about the optimal scheme for the sender when the sender signaling scheme is observed by the receiver. So this is the commitment case. And then we'll look at the optimal scheme for the sender when her scheme is not observed by the receiver. So starting with the preliminary results, let's think a little bit about what communication schemes might look like. So we have the sender, she has her posterior and access to a bunch of anecdotes. Here's some communication schemes she might select. One would be she's going to send the minimum anecdote. So this communication scheme just looks at all the anecdotes and always sends the smallest. Another communication scheme might be send the anecdote that's closest to 27. Another one would be, let's send the anecdote that's closest to my own posterior. Then finally, like, you know, what about if I want to try and shift my posterior? I could send the anecdote that's closest to some shift of my posterior. So these are all valid communication schemes in the context of our model because they're mapping from the set of anecdotes to a selection of one particular anecdote. What we're going to assume now, and this is one of the reasons I had little stars next to all of those theorem statements, we're going to focus attention on communication schemes that are translation invariant, which means changing the axis. I misspelled that word. Doesn't change the selection of anecdote. So if I shift the x-axis around here, the anecdote that's selected by pi will shift as well. And so this is assumption is actually, like, this seems supernatural because the prior for theta is diffuse, meaning that the state of the world is equally likely to be anywhere. So 27 doesn't really have any meaning. But there are sort of pathological examples which show that this translation invariance is not without loss of generality, and I'll refer you to the paper to look for those. So let's focus on, and we'll see shortly that this is the optimal scheme has this form. Let's focus on the anecdote closest to the shifted posterior. I wanted to find the bias of a signaling scheme and or communication scheme. So the bias of a communication scheme is going to be the expected distance from that communication scheme to, like, from the anecdote that's communicated by that scheme to the state of the world. So for this closest to shifted posterior type of scheme, if the R is 0, then the bias is 0 because I'm sending the anecdote that's closest to my posterior, which is itself unbiased. But as we grow R, the bias of this communication scheme is going to grow as well. And we can think a little bit about how does this bias grow with respect to the center that we're picking, which is R. Like, so the bias is going to, you know, the scheme says, let's pick the anecdote that's closest to the shifted posterior, where the posterior is shifted by R. But because we have this assumption that the distribution is single peaked, there's a bit more mass to the right. I've shifted to the left in this picture. So there's a bit more mass to the right than to the left. And what this means is that the bias of this scheme is going to be slightly smaller than the amount that I'm shifting this scheme by. Another thing you can see is that the bias of any scheme is always between 0, that minimum bias is 0, obviously, and the bias of the scheme that always sends the minimum or maximum anecdote. And that's because since we're sending anecdotes, we can never send something that's more biased than the expected bias of the minimum of k draws from this distribution. On the other hand, this target center, R, can grow without bound, and that'll become important later in the talk. So, okay, so we have this, communication scheme for the sender, And let's think about what the receiver is doing. So the receiver's posterior is going to depend on both the anecdote that they receive from the sender, as well as their perception of what scheme the sender is using, which we're calling pi r. What does the receiver do with this anecdote? So the receiver is going to look at the anecdote that they receive, and then they're going to think about the bias of the sender's scheme, which they're assuming is pi r, and they're going to try and undo the bias. So for example, if the sender sends the minimum signal, then the receiver is going to observe the minimum signal. And if the receiver naively didn't think about the bias, they have no other information about the state of the world. And so they would assume their posterior would be equal to the signal they were received. But they have some perception of the bias of this scheme. And so what they're going to do is they're going to shift their assumption or their posterior by what their perceived bias is, and that will be their updated posterior. Notice that if the bias of the perceived bias is equal to the true bias, then the receiver's belief itself becomes unbiased. So what is the sender's best response, given that this is what the receiver is doing? The sender wants to pick a communication scheme that's going to minimize this disagreement cost. And so there's several things that are standing in her way here. One is that she's unable to send arbitrary signals. And so she can't give the receiver super accurate information about her own beliefs. Another barrier is if the sender and receiver have gaps in their moral stances, then these actions are going to be attracted to their differing moral stances. And so that naturally pulls the actions apart and contributes to this cost. And finally, there's a potential mismatch between the true bias of the sender's scheme and the perceived bias. And so these biases, they will be equal in equilibrium, but the sender has a temptation to try and pull the biases apart such that the receiver will be updating with a bias that's not equal to the true bias, and thereby she can get his update to be closer to her moral stance. So using this, each of these barriers can be seen in a decomposition of the sender's cost. So we can rewrite this cost function, just plug in the formula for the optimal actions and do a little bit of massaging. And what you can see is that the sender's cost decomposes into three pieces that correspond to the 3 bullet points I mentioned about what's difficult about her minimizing her cost function. The first piece, which is the first line in this equation array, is representing that the sender is unable to send arbitrary signals. So this is just a signaling cost, we call it. It's the fact that the signal that's sent, the pi s of x, is simply can't be equal to theta of s because it has to be a signal, and so she can't send her own belief. The second piece is this fundamental loss in moral stances due to difference in moral stances, and this is something that the sender can't do anything about, and so we can ignore it for the rest of the talk. And the final piece is what we call the persuasion temptation. So here you can see that if the moral stances are different, so MS does not equal to MR, then the sender would like to, say, pull the bias of her scheme to the left in order to increase bias of pi s minus bias of pi r. And so we'll be using that decomposition of the sender's cost to reason about the impact of communicating anecdotes with and without commitment. But before we get there, let's think about the optimal translation invariant scheme with a fixed bias delta. So now I'm going to try and argue to you that this restriction to this class of translation invariant schemes that simply shift the posterior by some amount is without loss of generality. So in order to do that, I want to fix a bias delta and ask, what is the optimal translation invariant scheme with that bias? Is it like, randomized between the min and max signal with like some weighting of each, or is it something related to some shift of the posterior? And what we'll see is that it's actually a shift of the posterior. So here's a fixed bias, say delta, and I'm trying to find the optimal scheme that has that bias. And I'm going to argue that that is going to be shifting the posterior by some amount r of delta. So r is going to depend on delta. How far I have to shift the posterior in order to get that bias is a function of delta itself. And so to prove this, let's assume first that the signaling scheme of the sender has a particular, this particular bias delta. Then this is the formula that we had on the last slide about what the sender is trying to optimize. And the only piece of this that depends on her choice is, given this assumption that the bias is fixed to be delta, is the signaling cost. And so we can, through a little bit of algebra, rewrite the signaling cost to be a function of the shift of the center of the posterior. And what you can see is that this is going to be optimized by picking the anecdote that is closest to this shift. And okay, so we made an assumption that the scheme we were going to derive had bias delta, but notice that by definition, the scheme has the correct bias. And so that proves that the scheme is in fact optimizing among schemes that have bias delta. Okay, so now we know what the form of the best response of the sender is going to look like. And that's going to be very useful for arguing about the optimal schemes in the observable and non-observable regions. So just to summarize, what we've seen so far is that the optimal scheme is going to send the anecdote that's closest to some shift of the posterior. Now let's look at the optimal scheme for the observable regime. In the observable regime, what we're assuming is that the receiver knows the sender's communication scheme. So the receiver knows that the receiver's belief, pi r, about the communication scheme is equal to pi s. You could think about this as modeling worlds in which the sender can commit to a communication scheme. Say you're the New York Times and you're committed to having a liberal stance. And so everyone knows that, and you're going to select anecdotes that have liberal stances. Or it could be that the sender has a communication posture. Say there's a letter writer that you know is just always pessimistic and negative person, and so and hard to please, and so you know that they're going to send signals about people that tend to be on the pessimistic side. So given this assumption, the nice thing is that the receiver has the correct bias, right? They know the communication scheme, they know therefore the bias of the communication scheme. And so they can perfectly debias any signal they get. To make that more explicit, look at the cost decomposition again. And so this is the sender's cost, what she's trying to minimize. And what you can see is that the persuasion temptation is related, has this difference in biases. And so since the biases are equal, that is just zero. And the fundamental loss in moral stances, as I've mentioned before, isn't something that the sender can affect. And so that is we can also drop that out of our considerations. So the only thing we need to do in the observable setting is think about what would you communicate as a sender if you simply wanted to minimize this signaling cost? So you want to communicate something that's as close as possible to your posterior, also given the bias of the scheme, right? Now, what's very tempting to do is say, well, obviously you should just communicate the signal that is closest to your posterior. And this is almost trivial if the sender knew the state of the world theta, right? If the sender knew the state of the world theta, it's quite obvious that the optimal scheme is to pick the most representative anecdote, pick the one that's closest to theta. This scheme has bias 0, and it's also, and therefore it's, the closest signal is minimizing this loss function. But if the sender does not know theta, then we're still going to get the same result, but I want to convince you that it's not trivial. And the reason is because the anecdotes themselves correlate with the posterior. And so here's an example in which that shows, which shows this fact that the anecdotes correlate with the posterior. Let's suppose that the distribution is the uniform distribution. This is the distribution of anecdotes conditioned on the state of the world. Then let's imagine that the sender has 3 anecdotes to choose from. We see 3 anecdotes drawn from this uniform prior. The sender's posterior, about where the state of the world is going to be, is simply the average of the min and the max one. It doesn't care at all about the middle one, right? And so if the sender wanted to send the signal that's closest to her posterior, she would send the middle one. But that's not very informative. So this is the one that she would send if she's following, let's send the most representative anecdote. But in this setting, that's not informative, because it's much more informative for the receiver to see, say, the min, always send the min. Then I would know much more about the posterior of the sender. And this is because the posterior of the sender is more correlated with the min than it is with the middle. Or max, I guess. Okay, so in order to prove a result in this setting, what we're going to do is we're going to chop up the state space into tiny slivers, and the sender's posterior is going to be in one of these slivers, and these slivers will be tiny enough such that they don't contain any anecdotes. We'll then choose larger slivers to the left and right of the sliver that contains the posterior. And we want to choose these ones to be large enough such that they contain many points, but small enough such that the points in these intervals don't impact the posterior too much. And in particular, what we mean is that when you rearrange the points in these intervals, it has very minimal impact on the posterior. The posterior doesn't move at all. So now we've basically regained the independence that was useful for arguing why closest to the posterior was closest to the state of the world is the optimal anecdote. We can now, we've sort of in a sense regained that independence. And also, since all of these are tiny slivers, which I haven't drawn very well, but you should think of them as very small, the density in all 3 of these slivers is approximately uniform, and it's approximately equal to the density at the posterior. And so that allows us to calculate the signaling loss of any scheme which is a shift of the posterior. It's going to be the distance between the closest anecdote to that shift with some second order terms. And as a result, what we can see is that if the sender doesn't know theta, she will in fact, even though the anecdotes correlate with the posterior, if there's enough of them, she will find that the optimal scheme is to send the anecdote that's closest to her posterior. So the most representative anecdote, the one that's most representative of her beliefs, is in fact optimal. And furthermore, any biased scheme is suboptimal. And here's, if we go through the proof approach that I presented in the previous slide, we can in fact calculate and quantify the bias, the utility loss of the closest to the posterior scheme, which is bounded by some function of the number of anecdotes k and the density of the anecdote distribution at 0. And we can also lower bound the signaling cost of any other scheme with bias, with a fixed bias, and see that in fact, the most representative anecdote is an asymptotically optimal scheme. Yeah, and again, there's some technical restrictions on the form of this F. So this is what we've learned now is that the optimal scheme, and I think this is somewhat intuitive, so really the next part is maybe the more interesting part of the paper, but it's we needed to do this for comparison. The optimal scheme for an observable signaling communication scheme is going to be unbiased when we have large numbers of anecdotes, and it's going to send the anecdote that's closest. It's going to be the least noisy also, right? It's sending the anecdote that's most representative. Now we want to think about the world in which we aren't able to commit to our communication scheme. So if the receiver doesn't know the sender's scheme, then the fact that the receiver's assumption is correct is in fact an equilibrium condition. And so what we can see is, this is again our cost decomposition for the sender. As always, there's that fundamental loss that we can ignore. And now we can look at the first order conditions for the sender to try and understand what her optimal pi s is. So first observe that there is this temptation bias, right? If the perceived bias of the receiver is in some particular place, then the sender, has some signaling scheme pi s with some actual bias. And if the receiver's strategy is fixed, she would like to move the actual bias further to the left, such that the signal that's reported is further to the left and it's not debiased as much. And so this is the persuasion temptation. This is the second part of the sender's cost. As she moves this bias of her signaling scheme farther and farther left, it improves the persuasion temptation, right? It decreases it because ms minus mr is negative in this picture. But she has to trade that off with the signaling cost. So as she moves the actual bias of her scheme further and further left, she's getting a noisier and noisier anecdote, which is increasing her signaling cost. And that's what prevents the situation from completely unraveling. In fact, what we can see is with some algebra is that at equilibrium, and we have to leverage an additional assumption that the sender in fact knows the state of the world theta. The sender's scheme is going to be to select the anecdote closest to the shifted posterior, where the shifted posterior is characterized by the formula on the slide. That is the shift r minus the bias of the resulting scheme, which we write as pi r. Bias of r is related in some way to the difference in the moral stances. Let me remind you that alpha is the weight that in the action selection that the sender and receiver place on the state of the world, and 1 minus alpha is the weight they place on their moral stances when selecting their action. So here's some observations that we can read off from this formula. First, as R grows, the bias of the scheme is going to approach the min and max anecdote bias. And so as R grows, the difference between R and the bias of R is growing. What this means is that for any fixed number of anecdotes, as the moral stances diverge, or as the moral stances become more important, the the shift that you're targeting goes farther and farther left, and hence the bias gets larger and larger. So this is natural, right? This is saying that if the moral stances, like I have a lot more reason to try and persuade you because our moral stances are very different from each other. And so I'm going to send you more and more biased anecdotes. Or alternatively, our moral stances are super important to us and are more informative of our actions, then again, I'm going to have more and more temptation to persuade you to pull your action farther away from your moral stance. Perhaps more surprising is that for any fixed moral stances, as the number of anecdotes grows, then again, we're going to have this target shift going to infinity. And so why is that? That's because so we're fixing the right-hand side of the above inequality. And as the number of anecdotes grows, the difference between my target shift and the bias of the scheme that has that target shift is going to shrink as the number of anecdotes grows, because we get more and more observations. So we're more and more likely to see ones that are close to our target shift. And so what this means is that the sender with more anecdotes is going to have a more extreme signal that they're sending.
Nicole?
Yeah?
There's a quick clarification question in the chat from Abhinav Anandi. A basic clarification: does sender know receiver's moral stance in the unobservable setting?
Yes, the moral stances are observed and are known to both the sender and the receiver. And there's nothing that the receiver knows that the sender does not know. So it's total information asymmetry. Right, so what we're seeing here is that the for fixed moral stances, as the number of anecdotes grows, the bias also grows. And what this means is that since extreme anecdotes are noisy, first of all, for equal experience levels, so you can think about the number of anecdotes that someone has access to as being how expert they are, right? And so for equal experience levels, the receiver, well, clearly prefers to communicate to a sender with a similar moral stance, because they'll get less biased anecdotes, and those anecdotes have more information. But additionally, for differing, and this is what I think is the most interesting takeaway from the paper, when there's differing experience levels, so the receiver may in fact prefer to communicate with someone who's less experienced, but has a more similar moral stance. And why is this? Well, let's think about sender one as being some expert who has access to many anecdotes, but has a really different moral stance. Whereas sender two is a novice with very few anecdotes, but the moral stances are equal. Now, sender one, by the discussion we had on the last slide, is going to send some extreme anecdote, whereas sender two is going to send the most representative anecdote. And for Gaussian distributions, as the number of anecdotes grows to infinity, the max and min signal, which is the most extreme anecdote, has vanishing variance. And so even though the anecdote's very extreme, the receiver will be able to completely debias it. But for other distributions with slightly heavier tails, like say Laplacian, the min and max signal in fact have constant variance. And so the receiver might prefer to communicate with a novice who's sending the most representative signal, as opposed to an expert that's sending an extreme signal which has constant variance. And so what we've seen is that the optimal scheme for non-observable signaling schemes is biased for any number of observations when the moral stances are different, and that this can cause people to prefer to communicate with novices that are completely in alignment with them than with experts. So in conclusion, what we've learned in this talk, there was, we introduced a model of communication with anecdotes that we think has some interesting interpretations in today's world, where we tend to talk a lot about our experiences in short 128 character, tweets. And what we saw is that in this model, there's efficiency loss that's kind of obvious, because anecdotes are coarsenings of our own beliefs. This efficiency loss is less if the sender can commit, because then the sender will send the most representative anecdote. And without commitment, the sender might be picking biased anecdotes, and these biased anecdotes will result in even higher efficiency losses because there's more variance out in the tails. Fixing the number of anecdotes, this bias is going to grow with differences in the moral stances between the two individuals. That's pretty natural, because I'm trying to persuade you of something. I'm going to give you anecdotes that are closer to my moral stance. But also fixing the moral stance, the bias grows as the number of anecdotes grows, which is perhaps the most surprising result in the paper, and leads to the fact that for some priors and some numbers of anecdotes, the receiver might prefer to communicate with less informed senders. And so I think that, this is just the beginning of what could be a very interesting line of work. And what I would love to do, or see someone do, is to think about how this model informs the formation of social networks. So as we've seen, if you had many people you could listen to, but you have limited attention, who would you choose to listen to, and who would communicate with whom? How would that affect the structure of the networks that get formed, and how information flows, how beliefs and actions evolve, and how efficient our actions are? So thank you.
Thanks so much, Nicole, for a real nice talk. Now I'm going to open the floor for questions. And if you have questions, just feel free to unmute yourselves and ask it directly to Nicole. And in the meantime, let me ask you a very brief question, Nicole. So this without commitment part, there was the assumption that theta is known. And if I remember, theta is known to the sender, if I remember it correctly. And so the conclusions, some of the takeaways that you state here, like the fact that the signals are biased for in number of observations, etc. I don't expect that to depend on that assumption. So this is the first part of the question. The second role is, can you comment on the role of that assumption in the analysis?
Yeah, so Ozan's noting something that I tried to gloss over, which is that the setting, we call it foresight, which is the sender has foresight about the state of the world, and so they know theta exactly. And in the setting with commitment, we saw that with foresight, we were able to sidestep this annoying dependence on the posterior and the anecdotes, that those are not independent. And we were able to nonetheless prove that world, the result in that world without foresight, through this trick of dividing up the interval into slivers and basically decoupling those two things, the anecdotes and the posterior. In the setting without commitment, we had a harder time getting that to go through mathematically, but we believe that it should still work.
Thank you. If you, back to the audience, if you have any questions, please unmute yourselves and feel free to ask it.
Can I ask a question? Like here, I think you mentioned that for fixed moral stances, as the number of anecdote increases, the bias, which is something you construct, increases. I'm interested in what about the sort of the actual information delivering, or so the actual the action, so the agent choosing, does that necessarily sort of become more biased as the sender has more an anecdote? I mean, because it's possible that you know, when I have a very good anecdote, sometimes I can use it to deliver much information. So despite the fact that the bias increases, but it might overall that the information delivered has a higher quality.
So you're asking about how the action shifts as the bias increases, basically.
Sorry, because you know, on the one hand, the more anecdotes increase the bias, but on the other hand, the more anecdote might potentially increase the quality of the information. So I'm asking about the direct effect.
So yeah, so the thing is that more anecdotes, it could increase the quality of the information. For example, in the Gaussian world, where there's a lot of information out in the tails. But the point is that there are distributions in which there's not very much information out in the tails, and for those ones, there's still a lot of noise. So the receiver's posterior is going to be very noisy, and that's going to contribute to a lot of noise in his selection of his action, which is because the sender cares about the squared loss, is going to induce a high cost for the sender.
I see. Thanks.
That's a good question. I was trying to think of what, you know, when we send anecdotes and letters of recommendation and other kinds of things, ex post, the receiver actually learns the state and can, you know, then unravel a little bit of what we knew at the time when we sent the anecdotes. And I'm trying to figure out whether that moves it more towards commitment, or whether just in equilibrium there's no, you know, if ex post this, the receiver was learning this, and then over time I had a reputation that was, that, you know, does this sender send good anecdotes, or does that move us more towards commitment? Or
so you're saying, like, what if there's a reputation that I develop, like this is repeated and I develop a reputation over time? Yeah, this is kind of the justification I had in my head for why the commitment setting would make sense. Because, like, you know, we've learned over time that the New York Times is left-ish, left-leaning, and Wall Street Journal is right-leaning, or, like, you know, Professor A writes very enthusiastically about students, and yeah, Professor B is pretty. And so, like, I think that starts to sound like, I mean, I don't have a formal model of it, but it's kind of moves towards a world with commitment. And yeah, therefore, that's good, because then we're getting more representative. More
efficiency,
yeah.
Any final questions? So we are almost out of time, but Nicole, if there's a short answer, I was wondering the role of this assumption, the translation invariance. And feel free to say, just to get the paper for this one. I guess it's a technical one, but I was surprised that it is without loss. Any comments on the role of that assumption?
Yeah. Well, first of all, I hope it sounds natural.
It does.
In terms of it being without loss, it's a really annoying little example we have where there's like a peak left and right, and like it's a discrete distribution with anecdotes that have, like, I don't have a very good intuition for why that example has a non-translation invariant scheme. So I don't know that I want to get into I can tell you the exact example, but I don't know how useful it is in a few minutes time.
I'll check the paper. I was just wondering if there's quick intuition, but yeah, I was surprised that it's needed. And I think it's a pretty natural assumption.
Good.
All right. I think we're out of time.
I got a question.
Oh yeah.
I have a question too, if we have time.
Nicole, if it's not a problem to answer one more question.
Sure.
For example, for the system, let's say I am the sender and we have 5 days. So each day I'm gonna share one of my anecdotes with you. So in this approach, would your approach generalize to this setting in a greedy manner, or the sequence of the anecdotes that I'm gonna share with the receiver could matter too?
So even before you get to this, so I guess I'm assuming in your question, unlike Matt's, you're imagining that we take the action only at the end of the 5 days. And so then there's two things going on in your question. One is that in all of my discussions, we're sending one anecdote. And you're asking me, what if we send more than one anecdote? And the other is, what if we can label in order in which they arrive? And I don't have great answers to either of those questions. But yeah, that sounds interesting.
Okay, thank you.
Right. Nicole, there's one final question in case you have a quick answer. Is the paper online? I wasn't able to find it. It's a direct message I received. If you have any pointers to the paper, feel free to mention it.
Yeah, it will be online shortly. And I guess, do you link to papers from your seminar website?
I guess we can, Mohammed's, okay, sure, we can edit.
Okay, so I'll send you the link and when it's ready and you can post it there.
Sounds wonderful. Nicole, thank you for an amazing talk. Thanks for joining us today.
Thank you.